All right, folks, here we go. Q2 semester review, or basically quarter two semester review. All right, here we go. So it says, what is measurement unit for force? That's a Newton, right? Also just an N. These are kgs for mass, meters per second squared. Weight is going to be in newtons. Coefficient of friction, nothing. No label. That one's kind of tricky. All right, momentum is kilogram meter per second. All right, velocity is meters per second. Gravitational potential energy is joules. Kinetic energy is joules. Work is joules. And power is watts. All right, interpreting the graphs. Okay, so we got graph A. Describe the direction the object is moving. It is not moving. If it's changing velocity, 0 delta V, and 0 acceleration. Okay. B. Okay, so because this has got a positive slope, all right, positive, that means forward. Okay. So this one is moving forward. You could say left. You could say up, whatever you want to say there, right? Changing velocity. This is going at a constant velo, because it's a straight line. And if it is accelerating, because it's constant velo, this would have 0 acceleration. All right, graph C. This is actually going backwards. Right down. All right, this one is backwards. Negative, basically. A negative slope is that. All right, changing velo. Nope, this is also a constant. Velo. Is it accelerating? Because it's constant, there's 0 acceleration. All right, so part D. It is forward. So on and so forth. You know that. Is it changing velocity? Yes. This one is speeding up, or, right? Is it accelerating? Yes. Positive. Speeding up, basically. This one is increasing its velocity, just so you know. Okay. Part E, still forward. All right. It is slowing down. So that means decrease. And is it accelerating? Yep. It's a negative slowing. All right. Okay. Now, for this one here, remember when we look at V versus T, the positive V, the negative V, this is positive, meaning forward. This is negative, backwards. Okay. Graph F, the direction it's going forward, positive. All right, change in velocity, yes. This is increasing velo. And is it accelerating? Yep, it's speeding up. Okay, G, this is still going forward. Positive. All right, is it changing velocity? Yes. It's decreasing velo. And then is it accelerating? Yep, it is slowing down. Okay, direction is going. This is still forward and positive. Is it changing velocity? No, this is constant velo. Is it accelerating? No, this is 0 acceleration. Okay, so A through E, distance versus time. The slope represents here velocity. While the last curve's F through H, velocity versus time, that's going to be acceleration. All right. Okay, so this is fun equals mod type of stuff. All right, so we've got a 35,000 kilogram rocket in deep outer space, pushes it with a force of that. What is the acceleration? All right, so we got a mass equal to 35,300 kgs. We've got a force unbalanced equal to 125,000 newtons. So fun equals ma. So 125 equals 35,300 A divided by 35,300. A equals, let me get my calculator going here. So 125,000 divided by 35,300. Nope. 35,300. We get 3.54 meters per second squared. All right. 125 kilogram copper block is unbound, assuming G is this. If the block is, what is the tension on the cable? Okay, so for us here, this is just a fun equals ma one. All right, so we know our M is 125 kgs. We know our A is 10 meters per second. So our unbalanced force here is going to be 125 times 10. Our unbalanced force here is going to be 1,250 newtons. Okay. Number 12, see a speedboat. It has that much force with the throttle open. It experiences that much resistance. We've got a mass of that, and we've got a velocity of that. All right, so force net equals the boat's force minus the water. So that's 6225 minus 3725. Is that like 1500, I think? 6225 minus 3725. Yeah, 2500, sorry. That equals 2500 newtons. All right. What is the acceleration of the boat? All right, so that's going to be fun equals ma. So 2500 equals the 1250 A. A here should equal 2.0 meters per second squared. All right. Nope. Those three buttons are real helpful. How fast would it be traveling after 4.5 seconds? Okay, so it starts. This is my VI. So 2 equals VF minus VI. I'm using A equals VF minus VI over T. That's the equation I'm using, sorry. Oh, and this is going to be 4.5. This is going to be 2.5. All right, I'm going to cross multiply. So that's going to be 5 equals VF minus 4.5. Add over my 4.5 plus 4.5. VF here equals 9.5 meters per second. All right, 3 confused sled dogs. Alouetta, Seaward, and Kodiak are pulling. Alouetta pulls east, so 155 newtons that way. Seaward pulls the same way, 125 newtons that way. And then big old silly Kodiak, he's going to pull that way with 232 newtons. All right, so 155 plus 125. All right, so that's 280 going that way. So 280 minus 232. So minus 232. All right, so we get 48 newtons of force east. All right, just the difference. 2 ice skaters, Patrick and Nikki, are on the ice. Assuming zero pressure, they're standing at rest, facing each other. Nikki then pushes Patrick in a kind sort of way so that he ends up traveling east. So Patrick has a velocity of 4 meters per second that way. Nikki ends up with a velocity of 8 meters per second. That way, if Patrick has a mass of 100 kgs, what is her mass? Well, this is all about conservation momentum. So P equals mv. So, oops, sorry. So P equals 100 kgs times 4 meters per second. So that's going to be 400 kilogram meter per second. All right. So that's his momentum, which means that it's also her momentum. So then for us, P equals mv again. 400 equals her mass times the velocity of 8.00 divided by 8. Sorry. 400 divided by 8. Her mass is going to be 50 kgs. All right. Hope that's making sense.